Welcome back, our dear learners. Thanks for following up on the work we are doing. Please inform all your colleagues to subscribe. Inform them to subscribe to our platform such that you are not left behind if you want to improve on your grades. Here we are, and the topic we are talking about is none other than trigonometry. It is none other than trigonometry. After talking a lot of algebra, I found it wise to bring in a new topic, and that is none other than trigonometry. And this is our lesson 1 in trigonometry. So, what does it entail? Those are some of the things we are going to look at. What are the daily life applications of trig? We are going to look at all that here, but we shall focus much more on its curriculum because according to the Ugandan standards, we focus much more on the curriculum entailed in other words, the theory entailed in the trigonometry. That is what I'm supposed to talk about. So, trigonometry, it deals with analysis of angles on a triangle. Deals with analysis of angles of a triangle. Angles of a triangle. And it involves quite a lot of applications. It involves quite a lot of applications. One of them is the applications include among which the following. First one, we have measuring the distance between landmarks in astronomy. Measuring the distances between landmarks in astronomy. We have the second one. Enormously used in land surveying. It is enormously used. Mathematically, it is used in calculus. Mathematically, it is used in calculus. Then, I've said we have quite a number of applications where we're going to apply this topic. I've talked of measuring distances between landmarks in astronomy. Enormously used in land surveying. Those surveyors or land surveyors, they use this. We also have one of its applications in planes and spheres. to determine angles. Determine angles. And basically we can go with those applications for a time being. So we are saying that trig is the analysis of angles. Now we analyze angles in various formats. The various formats that I'm talking about are these applications. There are many, but I've looked at some of those ones which we know at hand. Now, in introduction, we make a quick review. Of trigonometric ratios. Which include the sine, cosine, and the tangent. So if we consider a triangle below, it is right angled in nature as you can see it. If this is side A, this is side B, and side C, if my angle is angle theta, now you can see that the side opposite to angle theta, I've called it B, but sometimes, since it is the side opposite to it, we can call it the opposite side. The side adjacent to the angle, I've called it A, but we can maintain and call it the adjacent side. And always this slanting side that connects the opposite and adjacent sides of the angle is what we call the hypotenuse, side. So if we are talking of sine, cosine, and tangent, for instance, the sine, now here these are full words. We can abbreviate them. Just like as I move on, I'll be abbreviating trigonometry as trig. So even these ones, I can abbreviate sine, this sine here, as sine without that letter E. So sine is opposite. That means the opposite side over, or the magnitude of the opposite side, or the value of the opposite side divided by the magnitude of the hypotenuse side. Then we have the cosine. So its short form is cos. So cos of theta is adjacent over hypotenuse. Then we have tan of theta. The tan is the short form of tangent, and that is the adjacent. Tan is the opposite over adjacent, and it is where this came from. So Sokatoa. That's where it came from. Where S stands for sine of the angle, O is the opposite, H is the hypotenuse, C stands for cos of the angle, A is the adjacent, H is the hypotenuse, T, that is the tan of the angle, O is the opposite, and A is the adjacent. So we are talking of, we're saying in introduction, we make a quick review of trig ratios, and those trig ratios I've said they include the sine, the cosine, and the tangent. Now, after that, we cannot talk of that, and we don't talk about the divisions involved in the angles. Angles in trig are divided into 4 quadrants, as shown below, I've said they are divided into 4 quadrants as shown below. Now, this one here is the first quadrant, and you always move in the anti-clockwise direction. The second one is not this, but it is this side because you are moving in the anti-clockwise direction. So this is the second quadrant. This one is the third quadrant. This is the fourth quadrant. Now, since I've said we move in the anti-clockwise direction, this is our reference, and the angle we start with is 0 degrees. Now, I'll mention these ones as I move on, but I just want to emphasize we are moving in the anti-clockwise direction. One thing I want to emphasize, in the first revolution, that is, if I move from here, I rotate and come back where I started from, I will have completed a full revolution, and that is, or a complete turn, that is up to 360 degrees. This is 90, this is 180, and this is 270 degrees. Now, in the first quadrant, you are going to find there angles less than 90 degrees. They range from 0 to 90, and those angles are called acute angles. These are the angles you are going to find there. Then, in the second quadrant, we have angles between 90 and 180. Those angles are called obtuse angles. Between 180 and 270, we have what we call the reflex angles. And so in the fourth quadrant. So all angles beyond 180 are referred to as reflex angles. Now, a quick reminder, I've said angles in trig are divided into 4 quadrants, and I've talked of these quadrants. We have the first quadrant having angles between 0 and 90. We have the second quadrant. Those are the ones with angles between 90 and 180. Then we have the third, angles beyond 180 up to 360 degrees up to 360 degrees. Something to note, I've mentioned it as I was talking, but I have to put it here. All angles measured in the anti-clockwise direction are positive angles, and the reverse is true, and the reverse is true. What am I meaning? I've said we measure angles in a trig. We measure angles in the anti-clockwise direction. When I talk of the anti-clockwise direction, you look at the wall clock. When you look at that wall clock, all the hands, that is the hour hand, the minute hand, and the second hand, they all move in one direction, and that is, they are taking, if I stand facing this side of the board, if you look at the whole clock takes, all the hands take this direction in their movement. Now, the opposite of that direction would be this. That's why we call it the anti-clockwise, because we are moving against the movement of the clock hands. Now, when we are determining our angles, we base on that kind of movement, and I've said that all the angles measured in the anti-clockwise direction are what? Are positive angles. Meaning, if you measure them in the clockwise direction, you'll end up with negative ratios. So we'll end up with negative angles. We'll end up with negative angles. So, having known that, we cannot fail to move forward and speak about the critical issues. Because we are dealing with angles, we cannot now fail to talk about what entails those angles. Let's go straight and talk about the trig ratios of 30 degrees and 60 degrees. One thing I want to mention here is, I've said trig is the short form of trigonometry. We have just looked at ratios, or the trig ratios. We have discovered we have sine, cosine, and tan. So when I talk of the trig ratio of 30 and 60, I'm referring to the sine of 60, cos of 60, and tan of 60, and so is the 30, and so is the 30. So we just need to consider an equilateral triangle, of whose sides is of magnitude 2 units. Now, all of us know what equilateral triangles are. They have some unique features, among which all their sides are equal. So if all their sides are equal, we have something like this. I've said all their sides are equal, and all their angles are equal. So if it is equilateral, remember, it is a triangle. The total angle sum of a triangle is 180. So if the angles are equal, that means that each of these 3 angles, because it is a triangle, it has got 3 angles, it must be of 60 degrees. Now we are saying the side, remember we have said the sides are also equal, 2, 2, 2. So even this one is going to be 2 here. the angles are equal and the sides are equal. We'll stop there.